Hello, my fellow Elmontians, and welcome back to another broadcast from the bunker. Today we're going to go over that review sheet I had sent out yesterday in the classroom. We'll go through how to work the reference table maps. You have to overlay the two, and then I'll give you an introduction to the next one. But first, let's start out. Today's due now. It's from Astronomy 8A, numbers 21 to 24. All right. Don't forget, for homework, make sure you're studying for the assessment that's coming soon on weathering, erosion, and landscapes. There is a bonus castle learning up. Make sure you polish that up so you can get some extra free points and some great review while you're doing it. All right, let's hit those do now questions. All right, so we'll start out with 21 over here. The apparent change in direction of a folk-called pendulum. Well, if you remember in the classroom, I had a bowling ball set up. Remember I told you I stole my sister's bowling ball a while back? Anyway, yeah, we set up that pendulum, and we started it swinging, knocking down the pins. And then over time, it would gradually change its course, right? And we said that was because of the Earth's rotation. So you got to go with rotation on that one. Remember, the magic number for rotation is 15 degrees per hour. But depending upon what latitude you have the pendulum set up, it will determine how long it takes to knock down all those pins. All right, either way, that is rotation, not revolution. All right, the next one, 22. There we go. Compared to Jupiter and Saturn, which are the gas giants, right, the Jovian planets, Venus and Mars have a greater what? So you got to run through the process of elimination here. Well, remember, Jupiter and Saturn are the outer planets. Venus and Mars are the inner terrestrial planets. But let's take a look at the chart if you want, right? Remember, your reference table planetary chart is here. The further down the column you go, the further away from the sun you get. And you'll notice that your distance is increasing here. Your period of revolution is increasing, right? All these things are increasing. So we're comparing the outer versus the inner planets. Well, then Venus and Mars would have a greater, let's see, size. No, the terrestrial planets are smaller. Speed, well, there you go. That's a possibility because the closer you are to the sun, the greater the gravitational pull, the faster you go. So go to the chart. That's going to be related to how fast it gets around the sun. That's a period of revolution. And if you look, Mercury, Venus, Earth, Mars all get around the sun in much less time than the outer gas giants. So you got to go with that one there. Not only are they faster, but of course they have a shorter path to take, right? So their years are shorter. All right. So they have greater orbital velocities. 23 deals with the diagram above here. At which position does planet X have the greatest orbital velocity? Well, again, the closer you are to the sun, the faster you go, right? Greater gravitational pull. So where are you closest to the sun? 1, 2, 3, or 4? Well, the sun is a star, right? So it got to be position 1 would have the greatest orbital velocity. And 24, which number indicates the position in which a planet would have the greatest gravitational attraction? Well, assuming all three planets have the same mass, which is very important because the two variables that affect gravity, as you recall, are mass and distance from whatever star it's orbiting. So in this case, it's saying they have the same mass, so the only variable that's changing is distance. All right? So greatest gravitation attraction would have the shortest distance. In other words, who's closest. So we'll go back to that diagram. Who is closest to the star there? Well, it looks like it's going to be 1 again. Is 1 an option? No. You got to go 5, 6, 7, or 3. So who's closest? 5, 6. So far, 5 is closest. 7 is further away, so 5 is still closest. And 3 is furthest away, so we got to go with number 5. Choice A. Okay. Hopefully you follow that. Any additional questions, obviously, post them in the comment section below. All right, let's jump into the lesson. Okay. And again, you guys worked on this yesterday, so I'm going to do a couple examples. Make sure it's polished up and submitted ASAP. Okay, let's take a look here. The first task I asked you to do was to find Elmont. Once you found it, figure out what type of landscape region it is, and of course what type of bedrock and how old is the bedrock. I know it sounds like a lot, but it's all in those reference tables charts. Let's start with coordinates. Elmont is right around here-ish, and the coordinates around Long Island are a little tricky to read because it's an incomplete grid, but if this is, we'll start with latitude. Always start with latitude. So here's 41, and that, of course, is north of the equator. So that's 41 degrees north. Well, we're south of that. So 43:30, right, halfway between 40 and 41, 30 minutes out of 60, is here, and that's below us. So we got to be somewhere between here and here, obviously. Well, that's just about in the middle of 40, 30, and 41. So we're going to say about 40 degrees and roughly 45 minutes out of 60. All right, again, that's north. So about 40 degrees and 45 minutes or so. That's approximate. I'll put the exact coordinate on in a second. Degrees north. And for longitude, well, let's see. Here's 73 degrees. We are west of England, so that's west. 74 is too far. So again, we end up in the middle someplace. And it's about 73 degrees 30 here, and we're a little further west, so about 73 degrees 40-something minutes again west. The exact coordinates, hopefully you got close to this. Those are your pretty much spot-on coordinates for Elmont Memorial High School. Okay, but what about the other pieces to that? What about the bedrock type, the age, the landscape? How do you get all that? Well, once again, head on down to Elmont. And, that doesn't want me to zoom too much on that one. Okay. Let me fix that up here. A little technical glitch. Give me 1 second here. Okay, so to figure out bedrock type and age, well, look at the pattern of Long Island. You have like these dashes with speckled dots in there. Kind of looks like this one here. So we're going to say Cretaceous and Pleistocene for the age. And for the type of bedrock, well, it looks like it's mostly gravels. Remember we talked about Long Island not having solid bedrock? Well, there it is, unconsolidated gravels, meaning loose sand, clay. It has not turned into sedimentary rock yet, and I'm sure if you've ever done any digging in your backyard or wherever on Long Island, you generally don't hit bedrock at all. You might hit a big stone, but that's not bedrock. So double check your answers there. Hopefully put it all together as the Atlantic Coastal Plain, and that was the info for Long Island, right? Cretaceous and Pleistocene, loose sediments. Our landscape is the Atlantic Coastal Plain. And no matter what place they ask you in New York State, you can find all this information out just from using those two charts. All right? So let's keep moving forward here. The two charts I'm talking about, of course, are the bedrock geology chart, and I just overlaid the landscape region chart. Okay? So take a look, Albany. All right, if it asks about Albany, of course, that's a place very near and dear to us. It's the capital of New York State, but more importantly, the place where your Regents exams are made. And of course, that's waived this year. But anyway, that's a beautiful city. Got a great music scene. If you ever head upstate a little ways, very clean city. Pretty different feel from New York City. All right. So anyways, find Albany, and of course, here it is. Look at the pattern there. It kind of has slashed lines. Slashed lines tell you Ordovician. It also tells you that it's a sedimentary bedrock. As far as the landscape region for Albany, well, take a look. It looks like it's in a lowland here. All right, so all that information. And as far as coordinates, well, here's 42 degrees north. Here's 43. It's about 3/4 of the way up. So we'll say about 42 degrees and roughly 45 minutes north. And for longitude, well, let's see. Here's 73, here's 74. It looks like it's in between the two, a little closer to the 74. So 73 degrees and a lot of minutes, maybe 40-something minutes. All right, so double check your answers. Did you have those coordinates roughly? Did you have down it was Ordovician? Did you have down it was a sedimentary bedrock, right? Limestone, shale, sandstone, those are all sedimentary. And for the landscape region, did you have it in a plain? Yeah, Albany is right on the Hudson River there, so it's a very low-lying area. A lot of major cities were developed around big rivers, as you recall from your history classes, because it helped with getting goods in and, of course, getting the garbage out. Okay. All right, so then you had to complete the rest of the chart on your own. I'm only going to do one or two of these, and then, of course, you polish it up. Again, it's using the New York State chart overlaid with the landscape chart. We'll start with Plattsburgh. Now, I gave you the coordinates this time, 44, 45, 73, 26. So that is way upstate, right? That's going to be way upstate New York. Let's double back here. So 44, you're looking all the way up here. That is the northeast side of the Adirondack Mountains. Just to give you perspective on how big Long Island is. That is easily a 6+ hour drive, okay? And that's doing 75 miles an hour. That is easily a 6+ hour drive. New York is a big state. So anyway, back to the meat and potatoes. It's in the slash part, and that tells us Ordovician. It also tells us sedimentary once again. The coordinates I gave you, and for the landscape region, take a look. It's in the Champlain lowlands. So when you fill in your chart, hopefully it looked something like this. All right, I'll do one more with you. Elmira. Let's find Elmira. Looking all around, and it's right there. All right. Again, that's probably about, I don't know, almost a 4-hour drive going that way. This one's in the polka dots, and the polka dots are Devonian. Devonian is known as the age of the fishes, and we'll talk about that when we get to Earth's history next chapter. But anyways, so it's Devonian. It's going to be, again, sedimentary. It's in this huge area here, which we call the Allegheny Plateau. The Catskills are a part of that. And as far as the coordinates, well, here's 42. It's almost right on the money, a little above maybe, so 42 degrees north in a couple of minutes. And for your longitude, well, here's 76, here's 77. This would be 76.30, so about 76 degrees, 45 minutes. Again, we are west of England. All right, put that all together on the chart. And what do you get? Well, those are our coordinates. There's your Devonian, sedimentary once again, and this time the Allegheny Plateau. All right, if you haven't completed this yet, please get on it. It's great practice using the two charts together, and in the next chapter, we're going to incorporate a third chart with it. There might have been one or two questions on the castle that incorporated the third chart. I'll show you what I'm talking about real quick. The third chart is the one with the fossils on it, but it also has all those periods and funky names on there. Here it is here. All right, take a look. Maybe some of these will look familiar to you. Cretaceous, Jurassic, Triassic, right? I'm sure you all saw Jurassic Park. There's your Devonian, Silurian, Ordovician, right? We were just looking at places in New York State that have that age rock. And this now combines it with animals and fossils that are found in that rock from that time period. So it's a really cool chart. It'll tell you how old it's inferred to be based on the fossil evidence. Really cool chart. It's got a lot of information. It's going to be overwhelming at first, but when you tie it together with the other three, it becomes a very powerful tool. All right, let's finish up with a couple summary questions. All right, which factor, remember these are stream drainage patterns here. When it rains, the water always flows downhill. Downhill could be any compass direction, right? Does not have to be south. Which factor is primarily responsible for causing these different patterns? Well, you got to go with the type of rock that's there. Remember, softer rock wears away faster. You get a low spot, water heads toward that low spot. Okay? What's the most probable cause of the difference in surface features between A and B? Well, A, if you look, looks nice and round. B looks much more jagged with cliffs. Well, what makes the rock nice and round and smooth? If you said flowing water, you're pretty good. So it's got to be a result of moisture, water, a humid climate, while B is more arid, a dry desert type environment. Okay? So please look over all the lessons in this unit, polish up that Castle bonus, and we'll have an assessment probably, what's today? Today's Tuesday? So yeah, I'll post the assessment, let's say on Thursday. You'll get Thursday and Friday to work on it, right? Have it done by Friday evening. Fair enough? Fair enough. Any further questions, type them in the YouTube section below, and of course you can use Remind as well. All right. Get outside, folks, in a few minutes, about 12:20, they're saying the Blue Angels are going to fly over Elmont, so that's pretty awesome. It's a beautiful sunny day to see it, so get on outside and check it out. All right, see you tomorrow.